In today's lesson, we are going to be looking at the sine law. So this is a possibly new concept, depending on what course you came from in grade 10. But this is what we can use, or one of the things that we can use when we're dealing with non-right triangles. So obviously, or not obviously, but we do know that there are triangles that might not be right angle triangles, right? The trig ratios that we've dealt with already, those are for right angle triangles. What we're going to look at in this lesson and next are for non-right triangles. So when we're dealing with non-right triangles, sine law is one of the things we can use. Now, we do need three pieces of information in the triangle to calculate using the sine law. And what we look for is what we call either a full or what we call a full pair and a half pair. So if I look at this triangle right here, I can consider the side length and the angle, so A and A, a pair. And in my triangle, there should be three pairs, an angle and a side, angle and a side, angle and a side. So those are three pairs. And what we want is we want a full pair. So we want an angle and its complementary side and half a pair. So that means either the angle or a side of another one. And we'll look at an example of what we mean by that when we go in and look at the different scenarios. But we want a full pair. We want a full pair and a half pair. And our formulas, when we're using them, there's two different versions, and they're very similar, except one's just flipped and the other is not. Right? So we want to use these for whether either we're finding side lengths, so the sides are going to be on the top, or when we're finding angles, the angles are going to be on top. And you should see, okay, we have three different ratios: A over sine A, B over sine B, C over sine C, or just the flipped version of that. And you'll see that again, like I said, the three ratios, but we're not always going to use all three, right? What we want is a full pair and a half pair. Here we see if we had all three pairs, but we're not going to be dealing with all three. We're only going to be dealing with two of them at a time. The formulas are just showing that the relationship is true between all the pairs. So let's look at an example. We want to use the sine law to calculate the length of side B. Side B is down here, across from angle B. Now my goal with using this sine law is to find a full pair and a half pair. I see a full pair here, an angle in its side, and I see a half pair here because I just have the angle, I don't have the side. Now again, we have to make sure that we're using sine law because this is not a right angle triangle. Even if you determine what this missing angle is down here because you know the other two, it's not going to be 90 degrees. So here we have to use the sine law or a non-trig ratio law to figure this out. So because I'm looking for a side length, I'm going to put that on top. So I'm going to start with B over sine B. And I'm going to use A, so little a over sine A. Your two fractions have to be consistent. So if one has the side length on top or the lowercase letter on top, so does your other fraction. You'll notice that we don't have the C over sine C like the formula does here. And the reason for that is because we have no information for C. So we don't have enough information to use that other ratio. Plus, we've never really dealt with an equation that had two equal signs in it. We're only used to kind of like one equal sign. So we're only going to use two ratios. It's going to look something like this. We're going to plug in our information. So we have, we have side B, we don't know what that is, over sine of angle B, or over sine of 76. And that is going to equal A over sine A. Oops, sorry. We do know what A is. Side length A is 22, and angle A is 60. What we want to do next, when we're trying to solve, is our missing piece should be on top, and we want to move the bottom piece of the one fraction up. So we're going to move that sine 76 over to the other side, and we're going to put it on top. So it's going to be 22 times sine 76 divided by sine 60. And that is going to be our rearrangement. That's going to be the only rearrangements we need. And now this is going to be one calculation. So B is equal to, now you may choose to do this all at once depending on how comfortable you are with your calculator. You could also do it in sections. So you could determine the top part and get 21.35 and then figure out the bottom. Sine 60 is equal to 0.866 and calculate and then divide those two numbers to get 24.7. So you could do that. If you're comfortable with your calculator, you could go, let me just change the color. You could go right from this step to here. You don't need to show the in-between. It just depends on how comfortable you are with your calculator. So you don't need to show this in-between part here. Let's look at a scenario now where we have to use sine law to calculate an angle. So here I want to find angle C. That is going to be this. Oops. That is going to be this angle here. And again, because we're asked to use sine law, it should be a non-right angle triangle, which we can tell it is. There's no right angle indicated. And we should have a full pair, which we do see here, an angle and a side, and a half pair here, a side but no angle. Right, so again, you want to make sure, again, non-right angle triangle, full pair, and a half pair. Make sure when you're drawing it or you're finding your pairs that you're using the angle and the side across from it. You're not going to pair up something like that, right? Because that is not the same pair. It has to be the side and the angle across from it. Because we're asked to find an angle, I'm going to put my angles on top. If I go back and look at the formula for finding an angle, I can see that my angles are on top of the fractions. So we're looking for angle C, so I'm going to write sine C over little c equals, and I'm going to use A because we're dealing with, that's the other pair we're dealing with. So sine A over little a. I can plug in my information. I don't know my angle for C, so I'm going to leave it as C. But I do know little c is 11, or side length C is 11. Sine A is 70 over angle A is 70, so sine 70. Side A is 19. And now I've plugged in my information. Very similar to the last one, the missing piece is on top. So I'm going to have to bring up the 11 to the other side and multiply. So 11 times sine 70 divided by 19. Again, we can go through and do this calculation, determine what the right side works out to. So I'm just going to do this all at once. So 11 times sine 70 divided by 19 is 0.544. Now you might look at that and say, that doesn't look like an angle. That seems a little bit too small. And you'd be right. there's one last thing that we have to do when we're finding an angle. If you think back to right angle trig with the sine, cosine, tan ratios, anytime we had to find an angle, we had to use the inverse. So we have to do the same thing here. So I have to do sine -1 of 0.544. And from there, I get my answer of 33 degrees. So you do want to make sure that when you're finding an angle, that very last step should be the inverse of your ratio. Very similar to when we were finding an angle for right angle trig, because there's a few more steps in the beginning that we have to do. So these are your two scenarios for sine law for non-right triangles. One, it's either finding a side length, right? Set it up so your fractions, your side lengths are on top. Bring up the bottom from the missing piece and multiply and divide and do your calculations. For finding an angle, put your angles on top. Bring up the missing piece or the given information. Do a few calculations, but the main thing as well is the last step should be the inverse. So again, this one's going to be new. It's a new concept for some of you. So again, take your time, practice, get used to rearranging, plugging information in, and going through and solving.